Now let's explain this phenomenon theoretically. Theoretical study. Theoretical study. The inconvenience first. Inconvenience of the wave theory to explain the photoelectric effect. Okay? At that time of the discovery of the photoelectric effect, there was the concept that light acts as waves only. فإذن at that history, the discovery of the photoelectric effect started at 1887, okay, and continued later to be explained in 1905 by Einstein. Before Einstein, light was considered as wave only. This is wave that has energy, because as you know, every wave carries energy. So any light radiation carries energy. فإذن radiation, since it is wave, it carries energy. Carries energy. Okay? Type. Suppose this is zinc. And this is an electron bounded at the surface of zinc. Bounded. Due to what is the bounding? The bounding, as you know, every electron, every atom has positive nucleus and electrons. So they attract each other. We say that the electron is bounded to the atom. Okay? These forces of attraction gives rise to what's called binding energy. energy بتكمش الالكترون بتخليها حوالين الاتوم. هلا هول الفورسز اوف اتراكشن بين الالكترون والنيوكليوس عاملين بايندينج انرجي حوالي 1.89 electron volt. What is the electron volt? I will talk about it later. It is a small unit of energy, and it is approximately it is equal to 1.6 times 10 power 19 joule, which is very small unit. Type. The electron here is bounded to the atom, يعني to the surface of the metal, by energy مكموشة بانرجي قيمتها 1. الفاليو تاعتها 1.89 الكترون فولت. برأيكم شو لازم تعمل الراديشن لتسحب الالكترون من الزنك؟ شو لازم تعمل؟ اقل شيء لازم تعطيها انرجي قد 1.89 الكترون فولت. اذا هيدي الراديشن عطت انرجي للالكترون قيمتها 1.89 الكترون فولت، هيدي رح تطلع من الزنك اوكي بدون سبيد. اذا عطتها اكثر رح تسحبها وذ سبيد. اذا عطتها اقل ما بتظهر الالكترون. اوكي الفكره مثل شو؟ اذا عم تسخنوا مي، اوكي اول شيء سخنتوا مي الغاز عم بيعطي حرارة للمي، المي ببلش يحمى شوي 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 شوي، بس يصير البارتيكلز للمي عندهم sufficient energy بيصيروا يظهروا من المي على الجازيوس ستيت. اوكي، نفس الفكرة هون. إذا هيدي الإلكترون تاخد 1.89 إلكترون فولت، فيها تظهر من الزنك متل. اوكي، اجوا بهيداك الوقت ما كان الا في فكره شو؟ فكره انه اللايت هو انرجي، هو ويف. اجوا قالوا بما انه اللايت هو ويف فاذا هو حامل انرجي باستمرار، عنده continuous energy، فاذا هو دائما عم بيعطي هيدي الالكترون انرجي. كيف المي كيف النار بتسخن المي شوي شوي، فهيدي عندها انرجي، فدائما عم تعطيها انرجي للالكترون. رح توصل لمرحله الالكترون تحصل على انرجي 1.89 الكترون فولت وتظهر من المتل. اوكي، طيب اذا الفكره كانت هيك، يعني حيلا ويف حامله انرجي لازم تسحب الالكترون من شو؟ من الزنك متل. حيلا ويف شو ما كانت اللمدة تاعيتها. اوكي، بس مثل ما شفتوا بالاكسبيرمنت هالشي مش مزبوط. في راديشن بتسحب الالكترونز وفي راديشنز ما بتسحب الالكترونز. بهيدي الحالة هيدي عملت وقتها مشاكل كبيرة للعلماء، عملت لهم بازل. اوكي، ليه؟ لأنه الاكسبيرمنتال ستادي ما اتطبقت، ما إلها تفسير عندهم، ما كان إلها تفسير عندهم، وضلت عملت لهم مشكلة لوقت أينشتاين بال 1950. اوكي، فإذا خلينا نكتب هون ليش الويف ثيوري انه اللايت كاريز انرجي ليش ما قدرت تفسر الفوتو الكتريك افكت. اوكي، since the radiation is a wave, it carries energy and it delivers it continuously to the metal. Okay, so at certain instant the sufficient energy is absorbed by the electrons on the surface that emit them from the metal. Okay, according to this concept, all radiation, يعني this implies all radiations should extract electrons from the surface of the metal, but this contradicts the photoelectric effect experiment that shows only convenient radiations extract electrons from the metal, which contradicts the experimental study. The experimental study. Okay. Einstein explanation. Okay. We said that this puzzle remained till 1905, when Einstein put his hypothesis to interpretation of the photoelectric effect. Einstein's hypothesis A. Einstein's hypothesis Einstein put a hypothesis that says any electromagnetic radiation of wavelength lambda or frequency nu consists of particles of energy, called photons, okay? Photon. That has no mass, no charge, moves with the speed of light in vacuum, and of energy equal h nu. Any electromagnetic radiation consists of particles of energy, that have particles of energy called photons. A photon has no mass, no charge, moves with the speed of light c in vacuum, and has energy E equal h nu. Let's see. A equal h nu. Nu is the frequency of light. Will E is the energy of a photon. Will H is 6.626 times 10 power minus 34 is called the Planck's constant. Okay. Why is it called the Planck's constant? Because Einstein took this formula from Planck. He didn't put this formula. He put this hypothesis, the concept of photons that has no mass, no charge, moves with the speed, and so on. So because of this constant is called the Planck's constant. Now, what do we mean by hypothesis? hypothesis فرضية. إذا قدرت تفسر الإكسبيرمنت نقبلها، إذا ما قدرت تفسره نرفضها. أوكي؟ طيب، بعد ما حط أينشتاين الهايبوثيسيس تاعيته، كيف فسر الفوتو إلكتريك إفكت؟ أوكي، this is the metal، هيدي الميتال. And you have here free electrons on the surface of metal. Okay? طيب. As you know, if this is a beam of radiation of wavelength lambda or frequency nu, part of the radiation will be will be reflected. يعني هولي اسمهم incident photons carried by the incident radiation. Incident photons. Okay? طيب هون part of the beam is reflected. So this called reflected photons. Okay? Reflected photons, ineffective photons, because they don't extract electrons, they are reflected as a mirror reflects the beam of light striking it. Also here the matter reflects part of the beam of light. So these are reflected photons and they don't extract electrons. They are called ineffective photons. Okay? Also, the remaining incident photon will be absorbed by the metal. تصون. Also here, this absorbed photons or absorbed radiation, absorbed photons. Okay. هلا part of this absorbed photons, part of them don't cause photoelectric effect. Photoelectric effect. هولي كمان اسمهم ineffective photons. Ineffective photons. هيدي الانرجي تاعيتهم بتروح هيت. اوكي؟ في عنا هون الeffective photons. في هون photons that cause emission of electrons. هولي بنسميهم effective photons. اوكي؟ عم نحكي هلا نحن عم نفسر effective photons. How do they extract electrons from the surface of metal? اوكي؟ مثل ما قلت من شوي عطيتكم المثل تاع الزنك. قلنا هون بالزنك الالكترون is bounded to the zinc at the surface with energy 1.89 electron volt. هلا هيدي الراديشن قلنا بتجي بفوتونز. عندها فوتونز. كل فوتون each photon interact with one electron at the surface and give it its energy. تعطيها energy. فإذا بصير عندي فوتون تعمل interaction مع electron. اوكي طيب اذا الفوتون عندها انرجي 1 الكترون فولت، يعني راح تعطي الانرجي للالكترون 1 الكترون فولت، فاذا ما فيها تظهرها، ما هي لازقه بالزنك ب 1.89 الكترون فولت. اوكي فاذا اذا اخذت 1 الكترون فولت عندها انرجي، الالكترون will stay in the metal. اوكي ما بيصير عندي emission. هلا اذا بنعطيها، اذا ببعث radiation، الفوتون الوحده عندها 1.89 الكترون فولت، شو بيصير بالالكترون؟ will leave without speed, will leave the metal without speed. واذا بعطيها مثلا 2 الكترون فولت، شو بيصير؟ الالكترون leaves the metal with the speed، يعني with kinetic energy. شو بتساوي الكاينتيك انرجي؟ فرق 2 minus 1.89 اوكي اللي بتعطيني 0.11 الكترون فولت. اوكي طيب فاذا فينا نقول in general the energy of an effective photon شو بها؟ is divided into هيدي effective photon. اوكي عندها انرجي A. الانرجي A عم تنقسم ل2، لا energy W node which is the bonded energy of the electron to the atom at the surface. اوكي ولا maximum kinetic energy of the electron when it is emitted at the surface. اوكي مثل ما قلنا the condition of emission، the condition of emission of electrons. أول شيء if A smaller than W node, there no emission of electrons, no emission of electrons. هلا if A بتساوي W node، هاي أول كيس. تاني كيس if A equal W node, electrons are emitted without kinetic energy, without kinetic energy. وإذا ال A greater than W node, the electrons are emitted with maximum kinetic energy at the surface of the metal, okay. Look here, when the electron leaves the metal, it will have maximum kinetic energy here, and as it passes through air, its kinetic energy decreases till 0. So the maximum kinetic energy here, maximum kinetic energy. يعني in this last case شو عم بيصير هون؟ energy is divided into W node and what? Maximum kinetic energy. So we can write for all cases that the energy of a photon is equal to W node plus maximum kinetic energy. Notice here, put here, if A equal W node, you get the maximum kinetic energy 0, okay? If A less than W node, you get maximum kinetic energy negative, which is impossible, which means that there is no emission. If A greater than W node, you will get maximum kinetic energy positive, which means that it has a speed, okay? Right. From this, let's define W node. W node is called the extraction energy or work function of the metal, okay? Right. Let's see what is the condition of emission. A أصغر من W node, no emission. A equal W node or greater than W node, and you can deduce it from here. A equal W node from plus maximum kinetic energy, which means that the condition of emission of electrons is A greater than or equal to W node. From this formula, I can deduce the definition of the work function. W node is the minimum energy needed to extract electrons from the metal. By meaning minimum energy is very important. Either you write minimum energy or you can write the energy needed to extract electrons from the metal without kinetic energy. So you should be careful when you asked about W node, definition of W node, okay? The last concept here, let's see it. As we said here, A greater than W node, which means that H nu is greater than W node, which means that nu is greater than W node over H. As you see, this is a theoretical condition. But the experimental condition, experimentally, mu greater than or equal to mu node. Yani this implies mu node equal W node over H. Yani this implies W node is equal H mu node. Okay? فإذا there is relation between the minimum energy or work function and the threshold wavelengths. This is joule times second, this is hertz, this is a joule, the SI system, okay? In vacuum or air, you can write mu equal C over lambda node and you get W node equal HC over lambda node, okay? That's all and good luck.